I am Dr. Shereena Bibi, Associate Professor, Department of Computer Applications, MES College, Maramali. Today I am going to discuss about the topic edge detection, and we are going to discuss about different types of edge detection operators in digital image processing. First, we will discuss about edge detection. What is an edge? Edges are significant local changes of intensity in an image, usually associated with a discontinuity in either the image intensity or the first derivative of the image intensity. So, discontinuities in the image intensity can be either step discontinuity or line discontinuity. Step discontinuity is where the image intensity abruptly changes from one value on one side of the discontinuity to a different value on the opposite side. Whereas the line discontinuity is the image intensity abruptly changes value but then returns to the starting value within some short distance. However, step and line or ridge edges are rare in real images or practical images. Because of low frequency components or the smoothing introduced by the sensing devices, sharp discontinuities rarely exist in real signals. Thus, the step edge becomes ramp edge and line edges become roof edges. So, there are four types of edges: step edges, ramp edges, ridge edges, and roof edges. First one is step edge. Here the image intensity abruptly changes from one value on one side of the discontinuity to a different value on the opposite side. It is given in the figure where first one is the ideal step edge and second one is the noisy edge. Second type of edge is ramp edge. Here a step edge is where the intensity change is not instantaneous but occur over a finite distance. That's also depicted in the figure given. Third edge is ridge edge. Here the image intensity abruptly changes value but then returns to the starting value within some short distance. The fourth one is roof edge, where a ridge edge where the intensity change is not instantaneous but occur over a finite distance. That is, it is usually generated by the intersection of two surfaces as given in the figure. Now we can see which are the edge detection operators. An edge detection operator is an algorithm that produces a set of edges from the image. There are two types of edge detection operators. First one is gradient based and the second one is Gaussian based. Gradient based operator computes first order derivatives in a digital image, and there are Sobel operators, Prewitt operators, and Robert operators for gradient detection. In the Gaussian based operator, we compute second order derivatives in digital images, and they are canny edge detector and Laplacian of Gaussian. This is given in the block diagram, that is the image edge detection operators divided into two types: gradient based, Gaussian based. And gradient based consists of Sobel, Prewitt, and Robert operator. Gaussian based consists of canny edge operator and Laplacian of Gaussian. In the gradient based operator type, we can see the mathematical calculation. For a function f of xy, the gradient of f at coordinates xy is given as the column vector given below. That is, del f is equal to gx gy, column vector gx gy, that is equal to dou f by dou x and dou f by dou y. The magnitude of this vector is given by del f is equal to magnitude of del f, that is gx square plus gy square, the root. That is root of dou f by dou x the whole square plus dou f by dou y the whole square. And also we can calculate the direction of gradient vector given by the angle measured with respect to x-axis. That is, alpha of xy is equal to tan inverse of gx gy. Obtaining the gradient of an image requires computing the partial derivatives at every pixel location in the image. So, a digital approximation of partial derivatives is needed. We can discuss the gradient based operators. First one is Sobel operator. It is a discrete differentiation operator. It computes the gradient approximation of image intensity function for image edge detection. And it uses two 3x3 kernels or mass which are convolved with the input image to calculate the vertical and horizontal derivative approximations respectively. The mask is given below. Mx is equal to minus 101, minus 202, minus 101, whereas My along the vertical axis is given as minus 1, minus 2, minus 1, 0, 0, 0, 1, 2, 1. The second one is Prewitt operator, which is almost similar to the Sobel operator. It detects vertical and horizontal edges of an image, and it is one of the best ways to detect the orientation and magnitude of an image. It uses the following 3 by 3 kernel or mask, where mx is equal to minus 1, 0, 1, minus 1, 0, 1, minus 1, 0, 1, and my is equal to minus 1, minus 1, minus 1, 0, 0, 0, 1, 1, 1. The third operator is Robert operator. This gradient based operator computes the sum of squares of the differences between diagonally adjacent pixels in an image through discrete differentiation. Then the gradient approximation is made, and it uses the following 2 by 2 kernels or mask, where mx is equal to 1, 0, 0, minus 1, my is equal to 0, 1, minus 1, 0. Now we can discuss about the second type, that is the Gaussian based method. The first operator we are going to discuss is Marr-Hildreth operator or Laplacian of Gaussian or LOG. It is a Gaussian based operator which uses the Laplacian to take the second derivative of an image. It works on the zero crossing method, that is, when the second order derivative crosses 0, then that particular location corresponds to a maximum level. It is called an edge location. Here, the Gaussian operator reduces the noise and the Laplacian operator detects the sharp edges. The Gaussian function is defined by the formula g of xy is equal to 1 by root of 2 pi sigma square exponential minus of x square plus y square by 2 sigma square, where sigma is the standard deviation, and the LOG operator is computed from the formula given below. Now, the second Gaussian based operator we are going to discuss is Canny operator. It's a Gaussian based operator in detecting edges, where the operator is not susceptible to noise. It extracts image features without affecting or altering the feature. Canny edge detector have advanced algorithm derived from the previous work of LOG operator. It is widely used in optimal edge detection technique. It detects edges based on 3 criteria. First one is low error rate. Second one, edge points must be accurately localized. Third one, there should be just one single edge response. These are the steps of Canny edge detection. First one is compute fx and fy, where the steps are given below. Gx of xy is the derivative of g of xy with respect to x, and gy of xy is the derivative of g of xy with respect to y. Second step is compute the gradient magnitude. Then third step, apply non-maxima suppression, and fourth one, apply hysteresis thresholding or edge linking. Now we can see what is a non-maxima suppression. Here, check if gradient magnitude at pixel location ij is local maximum along gradient direction. Standard thresholding is given as E of xy is equal to 1 if del of f of xy greater than t for some threshold t, or 0 otherwise. Here it can select only strong edges, and it does not guarantee discontinuity. As given in the figure below, the first figure shows the image, second one is gradient magnitude, the third one low threshold, and fourth one is high threshold image. Hysteresis thresholding uses 2 thresholds. The low threshold is T1 and high threshold is TH. Usually TH is equal to 2T1. So there are 3 cases: T1 greater than or equal to del f of xy greater than or equals to TH, definitely an edge, and the second case less than TH may be an edge, and the third case less than T1 definitely not an edge. For maybe edges, decide on the edge if neighboring pixel is a strong edge. So the idea is to use a high threshold to start edge curves and a low threshold to continue them. So the algorithm is as given below. Produce two thresholded images, I1 of ij and I2 of ij using T1 and Th. That is, since I2 of ij was formed with a high threshold, it will contain fewer false edges, but there might be gaps in the contours. Second is, link the edges in I2 of ij into contours. So the sub steps are, look in I1 of ij where a gap is found, and second is, by examining the 8 neighbors in I1 of ij, gather edge points from I1 of ij until the gap has been bridged to an edge in I2 of ij. These are some of the real-world applications of image edge detection. First one is in medical imaging, study of anatomical structures. Second one, location of an object in satellite images. Third one is automatic traffic controlling systems. And the fourth one is face recognition and fingerprint recognition. Thank you.